Hey there, science fans! Today we're talking about a critical piece of technology that keeps our lights on and our gadgets powered. Air circuit breakers, or ACBs for short. These heavy-duty electrical switches are like the guardians of the electrical grid, protecting our systems from dangerous overloads and short circuits. ACBs are designed to interrupt the flow of electricity when something goes wrong. Imagine a sudden surge of power, like a lightning strike or a malfunctioning appliance. This surge could fry your electronics or even start a fire. That's where ACBs come in. They act quickly to cut off the power, preventing damage and keeping everyone safe. ACBs are essential in a wide range of applications, from massive industrial plants and bustling commercial buildings to our very own homes. Wherever there's a need to control and protect high-power electrical circuits, you'll likely find an ACB standing guard, ready to spring into action when needed. So, next time you flip a light switch or power up your computer, remember the unsung heroes of the electrical world, air circuit breakers. Now let's dive into the nitty-gritty of how ACBs actually protect our electrical systems. One of their primary functions is overload protection. You see, electrical circuits are designed to handle a specific amount of current. When the current flowing through a circuit exceeds its limit, it's called an overload. Overloads can happen for various reasons. Maybe you've plugged in one too many appliances, or perhaps a piece of equipment is malfunctioning and drawing excessive power. Whatever the cause, overloads can be dangerous. They generate excess heat, which can damage wiring, melt insulation, and even spark a fire. This is where ACBs show their muscle. They constantly monitor the current flowing through a circuit. If they detect an overload condition, they quickly interrupt the flow of electricity, preventing damage and ensuring safety. Think of them as vigilant guards, always on the lookout for any signs of trouble. One of the great things about ACBs is that they offer both automatic and manual control over electrical circuits. This dual functionality makes them incredibly versatile and user-friendly. Let's talk about manual control first. ACBs have a big, sturdy handle that you can operate by hand. This handle allows you to switch the circuit on or off whenever you need to. Manual control is especially handy for maintenance and troubleshooting. Let's say an electrician is working on a specific circuit. They can use the ACB's handle to de-energize that circuit completely, ensuring their safety while they work. This manual control feature also comes in handy during emergencies. If there's a fire or another dangerous situation, you can quickly cut off the power to the affected area by simply flipping the ACB's handle. Talk about peace of mind. Section 4, fighting fire with air arc quenching in ACBs. Remember how we talked about overloads and short circuits causing sparks and potential fires? Well, ACBs have a clever trick up their sleeves to combat this arc quenching. An electrical arc is a continuous discharge of electricity across an air gap. It's like a mini lightning bolt that generates intense heat and can be very dangerous. ACBs are designed to extinguish these arcs quickly and efficiently, preventing fires and equipment damage. They do this using a special chamber called an arc chute located within the breaker itself. When an ACB interrupts a high current flow, an arc is inevitably formed. However, the arc chute forces this arc to travel upwards through a series of metal plates. These plates act like a maze, cooling and stretching the arc as it travels. This process rapidly cools the arc, causing it to extinguish or quench effectively. So not only do ACBs interrupt dangerous currents, but they also have a built-in firefighting mechanism. How cool is that? Section 5. Safety first is circuit isolation with ACBs. Another important function of ACBs is circuit isolation. In simple terms, isolation means completely disconnecting a part of an electrical system from the rest of the grid. This is crucial for maintenance, repair work, and ensuring safety. Imagine you need to replace a faulty component in a high-power electrical panel. You don't want to work on live wires, right? That's where ACBs come in. By opening the circuit breaker, you can isolate the specific section where you'll be working. This ensures that no electricity can flow through that portion of the system while you're busy tinkering. Circuit isolation not only safeguards technicians and engineers, but also protects the equipment itself. By isolating a faulty section, you prevent further damage from occurring and ensure that the rest of the electrical system remains operational. It's like putting a temporary out-of-order sign on a section of the electrical grid while you fix things up. Section 6, Fine-Tuning Protection Adjustable Settings in ACBs. Now here's where things get really interesting. ACBs aren't just simple on-off switches, they're highly sophisticated devices with adjustable settings that allow for precise control and protection. One of the key adjustable parameters is the overload current setting. Remember how we talked about overloads happening when the current exceeds a circuit's limit? Well, with ACBs, you can actually fine-tune this limit to match the specific requirements of your electrical system. This is crucial because different circuits have different capacities. For example, a circuit powering heavy machinery in a factory will have a much higher current rating than a circuit lighting your living room. By adjusting the overload current setting on the ACB, you ensure that it trips and interrupts the circuit only when the current exceeds the safe limit for that specific application. This level of customization ensures optimal protection and prevents nuisance tripping.